Okay, gentlemen, let's program these fourth axis parts. So we're going to start by setting up our coordinate system. Now, what you'll notice here is when I do fourth axis work, I generally have the fixture, the clamps, the stock, the body, everything in the model so I don't run out of clearance because it gets a little bit more complicated. So let's start out going to our manufacturer's forum. And what I'm going to do here is I'm going to hide parts, and I'm also going to hide this center stop. Because my coordinate system is based off of the center line of this big platen as well as the center line of rotation, which is the center of the platen. So let's create a new setup. I'm going to go over here to stock first, and I'm going to select from solid. I have to turn these back on. And from solid, that's my stock. So let's go ahead and turn them off again. Model orientation, Z-axis, going to be the top of this rotary platen. X-axis is already facing the correct direction. I just have to turn it around. Now I'm going to select the point. Okay, so in the model, I've already modeled this hole down to center line of rotation. So I'm simply going to pick that center line, and that's going to be my X, Y, and Z coordinate system. It's not on the part, it's on the fixture this time. And as far as the models go, we're doing 2 at a time. Okay, so I just hid the stock, and the models are these two. So I'm going to go ahead and hit OK. Now guys, let's go inspect that hole. Okay, so that's a 1032 hole. This hole is quarter inch, and that one is tapped 1/4 and 1/4. So let's start out by facing the bottom of the part. 2D facing. I'm going to select my 2-inch face mill, 2-inch 0625 radius face mill, 7,500 RPM, 100 inches a minute. This is all fine. I'm going to go to model top. I'm going to go to selection. Okay, so this is sort of important here. I'm going to do climb cutting, pass direction. I need it 90 degrees because I want to come across it in the y-axis, not the x-axis. And then I am going to try to see what it looks like with no stock contours. Okay, so that's going to face the bottom of both parts. Let's see what that radius is right there so we can see what size tool to get in there. 0.2 radius, so a 3/8 end mill would work just perfectly for that. Although I'm gonna hold off on that until I do the other side. So let's do let's spot every one of these. So let's spot them with the you know what? I changed my mind. Let's rough them out. We're not going to do any finishing operations along the contour of this, only roughing. So let's go to a 3D adaptive clearing. Let's use my 3/8 end mill. Let's go to 10,000 RPM, 120 inches a minute, and make the lead out 500. As far as the heights go, I don't want to go all the way to the bottom. I'm going to go just beyond that point there, 100 thousandths of an inch, negative 100 thousandths of an inch. And that should rough out roughly these corners as well as that pocket. Okay, while that's generating, I'm now going to spot drill with my chamfer tool, tool number 5. So I'm going to select every hole that's a different diameter. And then select same diameter. That should give me all of the holes in the model. Okay, so this is a spot drill. I don't want to go very deep. I'm going to go from hole top as my bottom height and just go negative 0.02. I'm just spotting it. Retract feed rate is 0. Let's change that. We can't have a 0 feed rate. 75. Let's take a look at what our 3D adaptive did. So our 3D adaptive just went along the part, roughed it out. I'm not doing any finishing operations, but the reason I wanted to rough it out is so that I can chamfer this edge. Even though it's not finished, when it comes around on the other side, it'll still leave a chamfered edge. So since we've got the chamfer tool in the part, let's go ahead and select my edges to chamfer. Why is my spindle ramp speed? Something's weird here. Let's make that 10,000, 10,000, 120, 120, and 120, and our ramp feed rate, let's just make that 120 even though we're not going to need it. Just an edge break here, so let's go 15 thou and 90 thou offset and 5 thou worth of clearance. Okay. So now I'm going to drill these holes using a 1/4 inch drill bit. I'm going to go ahead and set up 1/4" drill bit in tool number 20. $5,000 is fine. So if I select same diameter, okay, there's no reason to peck on this, but we do need to drill the tip through. Let's drill it through by 100 thou, and then just drilling and wrap it out. Okay. Now let's drill for our 1/4 tapped hole. So I'm using a form tap, which is different than a cut tap, guys. This is a form tap, so it forms the threads rather than cut the threads. So the drill size is different, but if you look in your machinist handbook or any of the tap drill charts, they'll give you the size for a form tap. So a 1/4 form tap drill size is a number 1 drill bit at 228. So that's tool number 9. I'm going to go ahead and select the same diameter. Again, no reason to peck. We will drill it through the bottom of the hole. And let's go 150 past the bottom of the hole. Okay, now these are 1032s. Tap drill size for a 1032 is a 156 drill bit. You can find that on your tap drill chart, you can find that in the machinist handbook, or you can just memorize it. I'm going to go with tool number 21. It's a drill. It's 156 in diameter. Our feed, let's make it 6,000 RPM. It's a small drill bit, so let's drop the feed rate down to 20. Again, just select one of the holes and select same diameter. One of the things about this is because I know the function of this part, that is a through thread, and the actual part that screws into it screws on from the opposite side. So we need to make sure we have a good thread all the way down. So go through the diameter, or select through the bottom, and let's go 0.3. Give ourselves plenty of room for tapping and the chips to go. Because that is a long length to diameter ratio, I am going to peck it. I'll peck it at 0.08 inches and go ahead and hit OK. So let's chamfer all of these holes, and then let's tap the tapped holes, and we'll be done. Or we'll be done with this side before we rotate it. So let's chamfer all the holes. Go to our 2D chamfer. Select our geometry. We have to select every hole. Chamfer width, 15 thou is fine. 50 thou chamfer tip clearance and 5 thou of regular clearance. And just so we don't wind up with any problems, let's turn our lead in and lead out off. Okay, we've chamfered the holes. Again, these are 1/4-20s. Let's tap them. drilling. I use a lot of 1/4 threads. I keep one in the library. I keep one in the tool at all times. It's tool number 10. Select same diameter. And again, I want to go through the bottom of this part. So I'm going to go negative 100 thousandths of an inch. What I am going to do is I'm going to double check that I drilled that deep enough. It's just barely deeper. It's not going to hurt anything to go 250. Give it a little bit more clearance. Now let's tap these 1032s. I do not keep a 1032 in the library, so let's call this 22. Tool number 22. Now I'm going to do something really cool here. I'm going to hit brake control. So it's going to check that tap after it uses it to make sure it's still there. I'll get you guys a video on that as well. Diameter is 190 thousandths of an inch. Pitch 32. So 1 divided by 32 is 0.03125. We don't need five-digit decimal place, but 4 is fine. Let's tap it at 1,000 RPM. And again, I need to make sure I have a good thread all the way through that part. So I'm going to go negative 0.2. Okay, what we have here is the bottom of this part done. Now you're going, Jeff, why'd you set it up on the 4th axis? Well, I'm going to rough this out. I'm not going to finish it, but I'm going to rough it out, and then I'm going to cut this hole and chamfer that hole. And it saves me setting it up on another operation, setting it up on an angle plate. And when I do the top side and the sides, I'll use the same 4th axis, so I'm not setting it up for just one operation. So, in order to do that, let's go to a 3D adaptive clearing. We can use the 3/8 end mill. Okay. And let's go 10,000 RPM. And 100 inches a minute. Lead in. Let's make our lead out 500. Our ramp will be 100 as well. So, you can see our z-axis is the way we programmed it before. Okay, I'm not going to select a machining boundary, but I am going to choose tool orientation. What that allows me to do is select a new z-axis and a new x-axis. Okay, so nothing changed as far as where our coordinate system was, but we've changed the orientation of it. And now our heights tab is now along our new z-plane, and the bottom of the part I'm going to choose right here. I'm still going to leave this 20 thou stock to leave on both the radial and axially. Because I am going to come back and clean this up when I do the outside, but I need to be able to get to that hole right there. So actually what I'm going to do is when I go to my face selection, I'll just rough that hole out as well. And then let's go negative 0.1. Make sure the radius gets all the way through there. Now let's see what we get. So while that's computing, let's go ahead and finish the edge of this hole with that same 1/8 inch end mill. We again have to choose the tool orientation, reset our Z and reset our X. Contour selection, we can select the contour. And because that tool, oops, needed to select it, because that tool has a 62 thou radius at the bottom. I'm flubbing this all up for you guys. Okay, I need to be below the contour by at least that 63 thousandths of an inch. So I'm just going to go negative 70 thou. Should give me plenty of clearance on that. Okay, so there's the roughing it out. There's the finish along that hole. Again, I'm not finishing this surface, or these radiuses, because I'll get them in the next operation. But I can chamfer that hole. So same thing, I'm going to do a 2D chamfer. Tool orientation. Every time you are outside of your normal tool orientation, you have to pick it. Contour selection. Fifteen thousandths of an inch is fine. Okay, since I know this question's coming from Robert, we are using the same tool 8 multiple times. What we can do is, because it's faster to rotate the 4th axis than it is to change the tool, just move this tool path up. Okay, we are using tool number 5 multiple times, but we kind of need to use tool number 5 multiple times. But what we can do is gang them up so that they are so we only have to do the tool change twice. So there it is, program the 4th axis part. Let me show you how it looks in simulation. So it just rotated the 4th axis. See how your tool orientation changed? You know, that's roughing that out twice. I could probably fix that. I'm going to turn off the tool path just to make it easier to see. Again, this is just a roughing pass. We'll come back and finish this on the next operation. There's the finishing pass of that hole. Now I've swapped the rotary back to this side. Drill all the holes. Chamfer all the holes. Come back, chamfer this hole after I've moved the A-axis. And I've drilled and tapped them. So that's it, gentlemen. That's your first fourth axis view of a program. We'll program the other side after we run these.